Hi everyone, it's Mr. Hamilton here. This video is all about logarithmic functions. So we've got two functions graphed in front of us. And the first one is one you should be very familiar with. That's y equals 2 to the power of x. Well, y equals 2 to the power of x is just put in the x values, and then the y value is 2 to that power. So for example, if we put in 2, 2 squared is 4. If we put in, that's that point right there. If we put in 1, 2 to the power of 1 is 2. 2 to the power of 0 is 1. Anything to the power of 0 is 1. 2 to the power of negative 1 is 1 over 2 to the power of 1, which gives me a half. And then 2 to the power of negative 2 is 1 over 2 to the power of 2, which is 1/4. So that's something we're very familiar with. But what about this other function? Well, what I've done here is I've taken this original y equals 2 to the x, and I've simply reflected it over this line y equals x. And when we do that, that is called an inverse function. And an inverse function is one where you swap the x and y variables. So it's x equals 2 to the y. So if you put in a y value of 2, 2 squared is 4. There's your x value of 4. And that's that point right there. If you put in a y value of 1 in, well, 2 to the power of 1 is 2. So there's your x value of 2. If you put in a power of 0, so y is 0, then we get x equals 2 to the power of 0, which gives us 1. And so we're kind of doing those points backwards to what we're used to doing. Well, I thought this was about logarithms. Well, what does this have to do with logarithms? Well, here's what I'm going to tell you. You rearrange this equation right here. What you're going to get is you are going to have to take the log of both sides, because that allows us to write that variable y out in front. So this is log x equals y times log 2. Well, if we rearrange that to solve for y, we divide by log 2. That cancels out log of 2 on the right side. And then we put it here on the left side. So we get y equals log x divided by log 2. A shorter way to write this is like this. We write it log 2x equals y. Well, what does that mean? It means 2 to the power of y equals x. So those two things mean the same thing. We've rearranged to show why that's the case. So they mean the same thing. In other words, if you have the base, that becomes the base of your log. And then if you have your y value on this side by itself, that becomes your exponent. And then the x that's here goes right on the left side. So that's just another way to write the same thing. So x equals 2 to the power of y is log 2x equals y. Notice that 2 is a little subscript that's written below there. It means the same thing as log of x divided by log of 2. Well, let's look at more about what this means. So first, in exponent form, we have this expression that b to the power of y equals x. And then in logarithmic form, which is just writing it without a power, in logarithmic form, if I look at m there, what it looks like is y equals log b x, where b is a subscript. Those two things are equivalent. They are the same thing, as we saw in the graph a minute ago. Okay? And so what we're saying here is this number b, raised to this number y, raised to y, is equal to this number. That's what that means. And so that's the way you can read that. When you start seeing logarithms, start training yourself to say, hey, the base raised to the y is equal to x. That's what that means. So what that means is that log a is an exponent. Log of b to the x is an exponent. That's what that means. So let's take some time to look at a few examples and see how this works. So here's one that says log base 2 8 equals 3. What that means is, and I'm going to write this out as a sentence so you can just visualize this and think about it. What exponent do I need on 2 to get 8? What exponent do I need on 2 to get 8? So 2 to the power of what? Well, 3 equals 8. So that's the other way to write that right there. 2 to the power of 3 equals 8. So our goal with these is to write in exponent form. And then we're going to go back the other way and write them in log form. So here's another one. Log 100 equals 2. What about the base? There's no base there, right? Well, anytime we have no base, what that means is it means that it is assumed by definition to be 10. And so what that means is 10 to the power of 2 equals 100, because this means 10. So we got 10 to this power 2 over here equals 100. A couple more here. Let's try this. Log 0.01 equals negative 2. This can be written, it's equivalent to saying that 10 to the power of negative 2 equals 0.01, because this is like a 10. Okay? One more here. D. This one we're actually going to have to solve. So this says log 5x equals 2. Log 5x equals 2. So what that means is it's saying 5 to the power of 2 equals x. 5 to the power of 2 equals x. Well, what does that mean? Well, that means that x is equal to 25. Those are equivalent expressions, and that's how you can solve what the x value actually is. Okay. So let's do 3 quick examples now writing in logarithmic form. Remember, this 3 is what you write down here. So that's log 3. 9 equals 2. That's how we write this. Log 3, 9 equals 2. Well, the next one, this would be log, the base doesn't need to be written if it's 10. So it's log 0.001 equals negative 3. So that means 10 to the power of negative 3 equals 0.001. Next one here. This is just rewritten maybe to help us graph it, for example. And so this would be log 5 x equals y. So that's how you do it. It's as simple as that. Let's look at some other facts of logs here. Call it trivia if you will, but here we go, some logarithmic facts. The first one is that log x equals 1. Well, what does that mean? It means x to the power of 1. So x to the power of 1 equals x, which makes sense. So it's got to be equal to 1. And then what about this one? Log x1 equals 0. That is equivalent to saying x to the power of 0, x to this power 0 equals 1. Here's a few others. Log a times 8, or log base a of a to the x is equal to x. That means this. It means a to the x equals a to the x. Well, why is that? Because it's saying this to that power is equal to that. So it's really saying the same thing. It's not really helpful to say that. Another one would be this. A to the power of log a base a x is equal to x. Well, let's think about what that means for a minute in terms of logs. So if we took the log of the left side, we would get log ax. That would be the exponent that would come out front. Log of a equals log of x. Well, let's rearrange that some more. This is divided by log of a. That's divided by log of a, which cancels out. And so that means that log ax equals, remember that if we divide two things, we write the a as the base and then the x there. So what these two things suggest is they're not really showing us anything different, but they're suggesting that y equals b to the x and x equals b to the y are the inverses of each other. That's really what those two properties are getting at with those. So let's wrap this up with looking at one example more of how this applies, as well as a table of values. So we're going back here and looking at the graph we started this video off with. We have y equals 2 to the x, that's the red curve here, and then the blue one is x equals 2 to the y, which we've learned to rearrange to become y equals log 2x. And so you can see here the table of values, all the values are switched. Now, down here in the blue one, it's listing them as fractions, where over here on the red, it's decimals. But negative 2 and 0.25 is the same as 0.25 or a quarter and negative 2. Negative 1 and 0.5 or negative 1.5 is the same as a half and negative 1. We've swapped the x and y values, but all the values are the same otherwise. 0, 1, 1, 0, 1, 2, 2, 1, 2, 4, 4, 2. It is the inverse of the other function. So here's the final example, and this is what really shows your understanding of logs. It says, find the inverse of y equals 3 log x plus 2 minus 4. Well, for an inverse function, the first thing we need to do is we want to switch x and y. Switch x and y. Because we know that's from the graph when we had y equals 2 to the x, the inverse was x equals 2 to the y. So let's go ahead and do that. So we're going to have x equals 3 log y plus 2 minus 4. We've literally done nothing except switching the x and y. Our next goal here is we want to isolate for y. The reason that gives us is it shows it in terms of x being the independent variable, because right now it looks like y is the independent variable. So we're going to just rearrange it so that we have y equals by itself. So then we can give certain x values and calculate the y value from there. So the first thing I want to do is I want to remember that I'm following the order of operations in reverse. So it's SAMDEB. So a subtract or add first, then multiply or divide, then exponents and brackets. The reason I'm doing it in reverse is because I'm not trying to solve something knowing all the numbers. I'm trying to undo what everything does. So I have to do it in reverse. So the first thing I'm going to do is I'm going to add, I'm going to do the subtracting or adding. I'm going to add 4 to both sides. So adding 4. So this gives me x plus 4 equals 3 log y plus 2. Now remember, log is like an exponent thing. So we're going to treat it down here like it's an exponent. So we're going to first now divide by 3, do the multiplication or dividing thing. And so we're going to divide both sides by 3. And so this is going to give me x plus 4 over 3 equals log y plus 2. Now the y plus 2 is in brackets, so we're going to do that last. But let's now work on the exponents. So how do I get rid of log? Well, remember that this means, the rule for log is that if I have log bx equals y, that's the equivalent of b to the y equals x. And so what that means here is that my base here is like a 10. It's not written there, it's like a 10. So it's saying 10 to the power of x plus 4 over 3 equals y plus 2. Equals y plus 2. So applying that property there, that's what we did, go from that step to that step, now allows me to finally finish with working inside the brackets. And inside the brackets, I apply SAMDEB again, but there's only one step, and that's subtracting 2 from both sides. And so what that looks like is y equals 10 to the power of x plus 4 over 3, or 1/3 x plus 4, minus 2. So you're going 10 to that power first before you subtract 2 from it. And that's all you have to do. That is the inverse of the original function, right there. And so that's the basis of what we have to do for today.